topic of the lesson is using integration for areas and volumes. So, to be able to find the area, if equation is Cartesian, means if y is equal to f of x, if this is the function f of x, and if we need to find the area between x is equal to a and x is equal to b, we use integration from a to b y dx. If the equations are parametric, x is defined in terms of t and y is also defined in terms of t, area is going to be from t1 to t2 y dx dt dt, because both y and x are in terms of t. Let's have two examples about area and learn how we are going to use integration to find area, both in Cartesian and in parametric equations. Example 1. Find the area under the curve y is equal to sine square x from x is equal to 0 to x is equal to pi. This is a quick sketch for y is equal to sine square x between 0 and pi. We need to find that finite area there. So area is going to be from 0 to pi sine square x dx. Now, can we do this integration? The question is, do we know an integration for sine square x? No. So we have to do a magic there. How? We have to use trigonometric identities. And the best one is using cosine 2x. We know that from P3, cosine 2x is equal to what? 1 minus 2 sine square x. You need to remember this, because sine square x has no integration. And the easiest way is to use some trigonometry that we learn. That we have to use a trigonometric identity to have a simpler one so that we can integrate much more easily. Here, 2 sine square x is equal to 1 minus cosine 2x. Sine square x becomes 1 over 2 in the brackets 1 minus 2x, cosine 2x. So area becomes from 0 to pi sine square x. Instead of sine square x, I am going to write its equivalent here. 1 minus cosine 2x dx. So take 1 over 2 outside of the integration because just a constant there. From 0 to pi, 1 minus cosine 2x dx. Trigonometry is very, very important. You need to remember all the identities coming from trigonometry to have easier integration. You have to remember them so that the integration is possible for you. So 1 over 2. What is integration of 1? It is x. What is integration of cosine 2x? It is minus 1 over 2 sine 2x. And the boundaries are from 0 to pi. That's the boundaries for given in the question. So let's substitute pi minus 1 over 2 sine 2 pi minus, put 0 there, 1 over 2 sine 2 times 0. So 1 over 2 pi, what is the value for sine 2 pi? This is 0. 1 over 2 times 0 is 0, minus, we have 0 there. What is sine 0? 2 times 0 is, that is also 0. So the answer is 1 over 2 pi. The area of sine square x from 0 to pi is 1 over 2 pi. For these, if you are not sure about the values, you can check them with your calculator. This is example 1 and it is Cartesian. Now we are going to do an example for parametric equations. Let's erase the board and continue with parametric equation. And I am going to give you an example so that we can work on parametric equations to find the area. Here you have to be careful. A is always less than B. What happens if A is greater than B? If that one is greater than B, you have to put a negative sign there. Or the answer is going to be negative and you have to say that you have to give the magnitude. Why? Because we cannot have a negative area. Area always has to be a positive number. You cannot have a negative area. Yes, let's erase the board to have space for example 2. Example 2. Say that y is equal to t cubed minus 2t and x is equal to t squared and find the area under curve defined by the above parametric functions from T11 to T23. So, what is the area if functions are parametric? Y dx over dt from T1 to T2. What is the x is equal to t squared. What is dx over dt? It is 2t. And we know the expression of y in terms of t as well. So area is going to be from 1 to 3, put y there, which is t cubed minus 2t. And what is dx dt? It is 2t as well, dt. So area is going to be from 1 to 3, expand this one, 2t to the power of 4 minus 4t squared dt. So area is going to be the integration of 2t to the power of 4 is 2t to the power of 5 divided by 5. And what is the integration of that one? 4t cubed over 3 from 1 to 3. So area is going to be found after substituting the given t values there. First of all, we have to substitute 3 to the power of 5 divided by 5 minus 4, 3 cube of 3 divided by 3 minus 1 to the power of 5 divided by 5 minus 4 over 3 cube of 1. So area is going to be 2 times 243 over 5 minus 14 over 15. So answer is 932 over 50. Yes, this is an example for parametric area under curve of a parametric function, parametric equation. Now, volumes. Volume. For Cartesian equation, volume is from A to B pi times y squared dx. For parametric equations, volume is pi times from T1 to T2 y squared dx over dt times t. Remember, y is in terms of t, also x is in terms of t for parametric equations. Example 1. How do we obtain, before example 1, how do we define volumes of functions? Volume of rotation. The definition is volume of rotation. And we use 3 sentences. You have to see rotated completely or rotated through 360 degrees or rotated through 2 pi. Let's give an example. If we have such a line, y is equal to f of x, and it's a line. If we rotate that line completely about x-axis, that means we are going to obtain a cone. That becomes a geometrical 3D shaped cone that has a volume. That's the same thing with curve. So, example 1. I'm going to give you a simple Cartesian equation so that we can find the volume very easy. Example 1 is always an easy one to learn what to do. So, find the volume of rotation of curve C with equation y is equal to 1 over root 3x plus 1 rotated completely about x-axis from x is equal to 1 to x is equal to 2. So, what is volume by integration? The definition is pi times from a to b y squared dx. So, volume will be pi times from 1 to 2. The limits are given. What is y? 1 over 3x plus 1 under the square root dx. But we have a square there because we are going to take y squared to be able to find the volume. So it is going to be pi times from 1 to 2. Square of 1 is 1. What is square of 3x plus 1 under the square root? It is 3x plus 1 dx. And we know that integration there, it is pi times, what is the integration of this one? 1 over 3 ln 3x plus 1 from 1 to 3. So the answer is going to be pi times 1 over 3 ln 3 times 10, 3 times 3, 9 plus 1, 10, minus 1 over 3 ln 3 times 1 is 3 plus 1 ln 4. So it is pi over 3 ln 10 minus ln 4, which is, when you have a subtraction here, it means a division. It is going to be pi over 3 ln 10 over 4, which is equal to pi over 3 ln 2.5. That's the answer for example 1. We have to remember that definition there for volume. Now we are going to do another example for parametric equations. We are going to find the volume of a parametric equation, of a curve with parametric equations. example 2. This is 3, y is equal to 2t plus 1, x is equal to 3t squared. Find the volume of evolution from x is 0 to x is equal to 3. Here, we don't know the x value, we don't know the t values. First thing to do is to find the t values, because we have to remember that if equation is parametric, volume is equal to pi times from t1 to t2 y squared dx over dt. And as you see, we don't know the t values here. So first of all, we have to obtain the t values. So when x is equal to 0, 0 is equal to 3t squared, t is equal to 0. And when x is equal to 3, 3 is equal to 3 2 squared, t squared is equal to 1, t is equal to 1, or t is equal to minus 1. But for this question, we have to have a restriction here. So we are going to get rid of this negative 1, because in the question it is given that t is equal to 0. So volume is going to be pi times the limit of the integral. Definite integral is from 0 to 1, y squared, which is 2t plus 1 squared, and dx over dt is going to, when x is equal to 3t squared, dx over dt is 6t dt. So volume is going to be pi times from 0 to 1, 4t squared plus 4t plus 1 is the expanded form of that one, times 6t dt. And volume will be pi times from 0 to 1, 24t cubed plus 24t squared plus 6t dt. Volume is going to be pi times from 0 to 1, 24t to the power of 4 divided by 4, 24t cubed over 3 plus 6t squared over 2 from 0 to 1. A simpler form of this one is 6t to the power of 4 plus 8t cubed plus 3t squared, and I'm going to substitute 1 there. B is going to be p times 6 plus 8 plus 3, which is 17, and when we substitute 0, it is 0, so volume is 17 pi. That's the definition. In the next lesson, I am going to solve much more examples about areas and volumes. That's the end of the video. See you next lesson. Bye.